Okay, welcome back everyone to the second part of our discussion on exponents and logarithms. Today we're going to cover some example problems applying what we learned last time. So the first question here is from the AMC, and it asks for the value of this expression here. Now this product seems to be hideously complicated because we want to apply the change of base theorem, which states that log base a of b times log base b of c is equal to log base a of c, because naturally this is a product and we have a product over here. But unfortunately, this number here isn't equal to this number here, and so we can't apply this directly. We need to look at this more deeply. Well, we do see that the 7 here corresponds to the 7 here. And we know that the 11 will correspond to the 11 in the next term here that's not shown. And for the terms that we skipped over, well, 9 that appears here also appears here, and so on and so forth. So we can still apply this theorem, it's just that we need to reorganize this product. So let's start with the first term, log base 3 of 7. If we want to apply this rule, we're going to have to write log base 7 of 11 so that we can simplify this expression. And of course, the next term in here would be log base 11 of 15, and log base 15 of 19, and then log base 19 of 23, and log base 23 of 27. And now we see that we've reached the end of this long product. So this is half of the puzzle. The other half includes the rest of the terms that we skipped over. So these terms would be log base 5 of 9 times log base 9 of 13 times log base 13 of 17 times log base 17 of 21 times log base 21 of 25. Yep, it ends at log base 21 of 25. So now all we have to do is evaluate this and evaluate this, which is actually pretty simple, because let's take a look at this one first. Focusing our attention on the first two terms, we see that this part simplifies to log base 3 of 11. And then taking log base 3 of 11 and the log base 11 of 15, we would get log base 3 of 15. And then taking log base 3 of 15 and log base 15 of 19, we get log base 3 of 19, and so on and so forth. So in the end, we end up with log base 3 of 27 as our answer for this part of the product. Now, similarly for the second half, we can look at these two first. That will give us log base 5 of 13, and then these two together would give us log base 5 of 17, and so on and so forth. So this part of our product would be equal to log base 5 of 25. So our product overall would be log base 3 of 27 times log base 5 of 25. Now, log base 3 of 27 is equal to 3, because 3 to the power of 3 is equal to 27. And log base 5 of 25 is equal to 2, because 5 to the power of 2 is equal to 25. So our final answer is 6, meaning that we would choose C as our final answer. Alright, this is the second problem. If you need to read a problem, pause the video here. So to solve this problem, we're going to cover another rule, which states that log base a of b is equal to 1 over log base b of a. You can think about this intuitively, or we can prove this by using a special case of the change of base rule? Well, by the change of base rule, we have that log base A of B is equal to log base C of B over log base C of A. That is what the change of base rule states. Well, what if we choose C to be equal to B? Well, then obviously we're just going to change these to B's. And then we see that the numerator log base B of B is simply equal to 1, because log base any number of itself is equal to 1. Therefore, we have shown that log base A of B is equal to 1 over log base B of A. So now this problem becomes a lot easier, because 1 over log base 2 of A is equal to log base A of 2. And similarly, 1 over log base 3 of A is equal to log base A of 3. And 1 over log base 4 of A is equal to log base A of 4. Summing all of these together, we get that log base A of 2 plus log base A of 3 plus log base A of 4 is equal to 1. Now, applying the product rule for logarithms, we see that since all of these numbers are base A's, we can combine all of them into one logarithm, namely log base A of 2 times 3 times 4. And 2 times 3 times 4 is 24. So log base A of 24 is equal to 1, and obviously the value of A is 24. So 24 is our answer. Alright, this is going to be the third and last problem we're going to cover in this video about logarithms. And it states, if log of xy cubed equals 1 and log of x squared y equals 1, what is log of xy? So to solve this problem, let's first simplify these three expressions here. And starting with this one, log of xy cubed, according to the product rule, is log of x plus log of y cubed. And according to the power rule, this is log of x plus 3 log of y. So we have that log of x y cubed is equal to log of x plus 3 log of y cubed. Similarly, log of x squared y is equal to log of x, two of those, plus log of y. And log of xy is log of x plus log of y. Alright, so to make this easier, I'm going to let a equals to log of x and b equals to log of y. This is so that, actually, oops, this 3 shouldn't be here. This is so that I can write the problem in terms of a's and b's. And we see that the first equation would be changed into a plus 3b equals 1. And the second equation would be changed into 2a plus b is equal to 1. And the expression that we want to find is a plus b. So I'm going to copy this over to the next page. Alright, here we go. So we want to find a plus b. Now, of course, you can just go ahead and solve this system of equations. It should be relatively easy. So if you want to solve for a and b, first we can double both sides of the first equation, and we'll get 2a plus 6b is equal to 2. And now since we have 2a plus b is equal to 1, we can subtract 1 from both sides, and we would get 5b is equal to 1, or b is equal to 1/5. And then you can plug this value of b back into either equation to get a is equal to 2 over 5. And so a plus b is equal to 3 over 5. But of course, there is a cleverer way to find a plus b without finding a and b individually. And to find a and b, we can simply double the second equation to 4a plus 2b is equal to 2. Then we add the two equations together to get 5a plus 5b is equal to 3, and so a plus b is equal to 3 over 5. As you can see, this is much quicker, but it requires some intuition and insight. Since a plus b, or log of xy, is what we want to find, 3 over 5 is our final answer. Alright, so this concludes our discussion on exponents and logarithms. Thank you for watching, and I'll see you next time.